Experimentation is one of the crucial steps in machine learning. Now, by learning this experimentation tracking tool, you'll be able to 10x your workflow productivity while working in collaborative environment. In this video, we're going to explore about these experiment tracking in MLOps. I can't wait to help you in your MLOps journey. If you're new to our channel, subscribe to us and check out the link in the description to join our WhatsApp community to get the new notifications whenever we are seeing you live. When we think about MLOps at a very high level, we are trying to combine the machine learning and DevOps practices, and we are trying to bridge the gap. So we are trying to combine this machine learning and DevOps practices so that we get to have a repeatable behavior when we are building an application, and we'll be able to have a efficient way to deploy the models as well. Now let's take a step back and think about the machine learning process. Now, if you remember, in our earlier session, I've talked about what happens in case of machine learning. See, if you think about it, in the case of machine learning, it's made up of three things. So it's made up of the data, and it's made up of the machine learning code and configuration. Okay, so our machine learning model is made up of basically three things. Like in order to generate a machine learning model, these are the three things that we have to keep in mind. Now, if any one of these changes, okay, whether it is data changes, machine learning code changes, or the configuration changes, in all those scenarios, we need to generate a new model. Now, here's the thing, guys. As a data scientist, if you're trying out the various combinations, we call it as an hyperparameter, which are basically the setting of the machine learning model. When we try out these various settings of these hyperparameters, for each setting of the hyperparameter, we are going to generate a new model. Let's say as a data scientist, you will try out, let's say 200 different types of combination. Maybe you're trying to run some job, or it can be something. Let's assume that you have conducted 200 different types of experiment with various changes on data, with various changes on code, the logic, and the configuration, that is the hyperparameters and the different set of values that you wanted to try out. Now, out of those 200 different combination, let's assume that you have to go back to 150th combination. Very difficult to track manually. No one remembers about what happened in the 150th trial out of 200 trials that have been completed. It's not manually possible. Now, it's not just about the model itself. Like, it's not just about that particular single hyperparameter setting. It involves everything. It involves the configuration, machine learning code, and data. So to track all these things, we make use of the experiment tracking tools, especially in the machine learning workflow. And that's the topic of today's session. In today's session, we'll be learning about how we can track such experiments. And we'll also have a quick hands-on as well, where I'll take you through about one of the library that we would use it. That's called as the MLFlow library. I'll take you through that library, and then from there you'll be able to understand, okay, how exactly it will be working. So let's get started. Now that you have a quick idea about what exactly is this, the experiments that a machine learning engineer would conduct, let's have a formal introduction about it. Now, when I say experiment tracking, so here, as we have described earlier, it's consisting of data, model, and the configuration, right? Combination of this is what we call it as an experiment or a trained model. If you consider this complete MLOps, whenever I talk about the experiment tracking, it's about using a specific version of a data, performing the model training with a specific model architecture, and evaluating on that model architecture. And we have to save the model so that we'll be able to have a repeatable model deployment. So this highlighted part over here, is what is made up of the experiment tracking. Now, to manage the source code, we have the GitHub. Now, to manage the data, that is data versioning, to perform this versioning of the data, we have the tools such as DVC. Now, how can we track the experiments? Now, that's the question that we are going to answer in today's session. Okay, so by efficiently tracking such experiments, like by monitoring the training, evaluation, architecture, and even saving the model with a specific versioning format, so that we'll be able to have it in an interface. So that's where the experiment tracking comes handy. So with this experiment tracking, we'll be able to track the experiments in an efficient manner where we can systematically record the machine learning experiment. We can ensure the reproducibility and accountability. So accountability is one of the key things that we want to establish whenever a machine learning model is being developed, so that we know what team has taken what decision. So that's going to build the accountability in the organization, as well as for the outer world, the organization as a whole will be accountable. And with this experiment tracking, we'll be able to track the parameters, the code version, data set, and the results that we have got. So all these will be able to do with this efficient experiment tracking. In MLOps, the experiment tracking is very much crucial because this is the one that's going to enhance reproducibility, which means the scores that, let's say, a team member one has got, we can replicate it in other environments, in quality and production as well, because that's one of the key challenges that we have in machine learning. And this is going to facilitate collaboration. It's going to improve the model performance, and it's also going to streamline the debugging and optimization. That means since we are able to track to which version what performance that we are getting, this is going to help us in go to that specific version and see if we can optimize more. So that's the next step that we can do when we are able to track the experiment. And here, when we think about the experiment tracking from the MLOps project standpoint, so these are the key components that makes up the experiment tracking. We have the parameters and hyperparameters. Parameters are nothing but the default values or the default things that we'll be specifying, and hyperparameters are nothing but the values that we have to manually feed in for our machine learning models to train. And parameters, we generally call it as the ones which is what we are going to get from the output, the model output. And the other components of experiment tracking is code and version control of the code, the data sets and versions, metric and results, and the artifact and models. So all these makes up the core components of these experiment tracking. Now, in order to track the experiments in an efficient manner, we have various tools in the market. And we are going to see one such tool in our demo today. So, to name a few, we have MLFlow, which is one of the most commonly used tool, and it's an open source platform for managing the entire machine learning lifecycle. Now, this has got an integration with various cloud services as well. For example, it has got an integration with AWS SageMaker. So we can track the experiment using MLFlow inside the SageMaker AI, which is part of the AWS cloud. And the other tools that are very much common these days are Weights and Bias, which is another tracking and collaboration tool that we have got. And we also have Tensor Board, which is like a visualization toolkit that we use it. And to talk specific about the data, we have DVC, and we also have Neptune.ai, Comet ML. So these are the various tools and technologies that we have, which will enable us to track the experiments in an efficient manner. Now, apart from that, The main advantage that we are going to get is we'll be able to streamline the workflow. Now, with this versioning and when we are able to replicate it, we'll be able to confidently integrate to our CI/CD pipeline because we know what specific setting has resulted in what performance. And another best part about this is we can automatic log as well. Like whenever an experiment is happening, we can automate these experiment logging. Like for example, we can log it into a database. Like let's say there are five people working in a machine learning project. Five different folks will be working, and they are going to log it into a single database. So at any single point of time, they'll be seeing the various experiments from the individual team members and its performance. And yeah, like this in turn, we'll be able to utilize this centralized dashboard because we are saving at a single place and we can make use of the centralized dashboard from the data that we have logged. We can also implement the continuous monitoring about how well the model is getting trained. With like if a particular team member is increasing the hyperparameter value, we can get to see whether the metric is improving or not. Like for example, if I'm using a decision tree as an example, if I'm increasing the number of decision tree, we can actually we can generate the graph inside this MLflow itself to understand with the changes in the various experiments with the various values, hyperparameter values that we have set, whether the performance is increasing or decreasing. And this in turn is going to create a collaborative environment where all the team members will be working as a group to get the best model for a given data set by combining their work instead of working in silos, which could result in duplication of work. So this is one of the an essential component, especially while working in data science teams. Now that you have an introduction about why and what, let's have a quick hands-on about this so that you will be able to see it in action. You can grasp everything in detail. So I'll talk more about it on our weekend webinar, but I hope this gave you a clarity as how this experiment tracking and why is it important. Okay, let me just give you a quick demo of this MLflow. So here for this demonstration purpose, I'll create a new folder. Okay, I'll show the demonstration folks. Okay, so I've created a folder. Now let me just go ahead and I'll just mention the code that I have got. So I'll mention my code like this. I'll say main.py. So this is the Python script. Now here, let me just explain what is happening in this code. Okay, let me just quickly add the comments. All right. So here, if you take a look at it, okay. So we are importing the necessary libraries. So I'm importing the logging, which is one of the standard module for creating the logs, and to parse a URL. So we are going to conduct the experiment and post it on a specific URL. Hence, I'm using this URL parse and importing the other libraries such as NumPy, Pandas, and some models. And just observe right here. Here, I'm importing the MLflow and I'm also importing the sklearn module, which is present inside this MLflow. And I've started logging right here. I'll say initializing the logger to log the information. So this is going to initialize the logging, which will be helpful for us to check the progress and to look into the errors. This will basically help us in the evaluation and debugging. All right. So here in this case, we have created some function which is going to perform certain things. Like there's one function which is going to evaluate our model. So this is going to check whether our machine learning model that we have got, whether it's working as per the metrics. So some of the metrics that we are using right here is root mean squared error, mean absolute error, and R2 score. Now, these are all the common metrics that we use it for evaluating the regression task. And the same is what we are calculating over here. And there's one function that has been created to initialize the linear regression model. There's another function that has been created to initialize the random forest regression model. And observe right here. Now, when someone calls this main.py script, okay, what we are doing, I'm just getting the data set. And once I get this data set, I'm going to split the data set into two parts. Here, in order to start capturing the logs, so we will have to mention the code inside this MLFlow.start run. Now, this is going to start the run for us. Okay. And then we are going to perform the fit on our data set. So first thing that I'm using is I'm using the random forest model. And this is like a model one. And I'm performing the fit on my data set. And I'm calculating the metrics. That means I'm measuring how well my model is performing. Then, in order to log for our future reference, we make use of mlflow.log underscore metric function to log those individual variables. Now, this will help us to log those variables and we can refer it at a later point. You'll be seeing everything in action. Like when we look into the dashboard, you'll be able to see. So just remember, these are the ones that will be made available to us to look at it at a later point because these are important for us. Then I'm logging the parameters of this model. Then I'm performing some kind of prediction. I'm looking into the format of my data set. And once it's done, I'll go ahead. I'm mentioning it as I'm getting some tracking URL and I'm logging my model as well. Okay. And let me do one thing. Add a similar code for linear. I'm just going to generate a few more code. So here, what we have done, it's for a single model. I'm just doing one more model over here in the same block. Let me, okay. So let it be like this. Now I've just got the code right here with me and it looks like fine at a very high level. So let's go ahead and execute this code. So I would go ahead and start the same. So first thing I need to do is I need to start this MLflow UI. I need to start this MLflow UI. Or the another thing that I need to do is in order to ensure that I'm able to log it, I need to start this MLflow server. So this is this MLflow folder. In order to start this server, I'll just mention my code. The code is something like this. I'm going to add this readme.md file. I'm going to mention it as an attachment so that you will be able to access the zip file under the video at a later point, folks. Okay, so I'm just going to ensure that this MLflow server is available in the port of 5000 and it's able to create the logs. Okay. Okay, so currently it says 5000 is being used. I'll say 5002 for my case. Okay, so now what it says is, it says that the server is listening in the port of 5002. Okay, that's what it says. Now, if you go to this 5002, that is localhost 5002 port, this is the MLflow user interface that you're going to get to see right here. Okay, now what I'll do right now is just give me 1 second. I'm just extending this call. Okay, it's done. All right, so this is the interface, which is called as the MLflow interface. Now that my server is available and my MLflow server is running on this port of 5002, I'm going to run my Python code so that it can start logging in this server in the port of this 5002. I'll just open a new tab and I'll simply say Python main.py. So now this file is starting. It's trying to read this file. Okay, let's see what is the error that we are getting. Just give me 1 second, folks. In the meantime, just confirm the same. So it looks like it's related to the tracking URI. Let me just fix it and see if it works. MLFlow dot. Okay, so I just had to create an experiment, and now once it's done, see, we can see some logs that's getting populated. So first thing it says is random forest model. These are the three metrics, RMSE, MA, and R2 score. It has successfully registered the model. Then a linear regression model, and it has successfully registered this linear regression model. Now, let's go back to the server where our MLflow is running. If I refresh this page, okay, I'll just click on this refresh button. We can see that this is the run that was created. Okay, and if I just expand this, there are two models actually. So see, actually I don't think so. It's a good practice to, yeah. Okay, if you look at this let me just come to the experiment first. I'll click on this run name. If I click on this run name, we can see the various things that have happened right here. If you look into the metrics, these are the 6 metrics that I have actually got, because in this case, in a single script, I have made use of two models. So generally we run single setting with a single run. That's a common practice and the best practice. So in my case, I had added it for the demonstration. And as a result of this, we can see all the metrics that are being added, and we are able to see it under this metric section. If I expand the parameters, see, these are the model parameters that we are logging, and these are related to the random forest model. Okay. And then if you take a look at it under the artifacts, we can see two artifacts that are present. One is a linear regression model, which basically has got the environment related to our model so that it can work with. And this contains the complete information. It says what is the model and where exactly the model is present. The model is model.pkl, and predict function name for prediction of output is predict, and it mentions about the signature. What is the data type of my input? What will be the data type of my output? Everything that's present right here. We have the model file, the environment file. That means in case if you want to replicate it in a new environment, what are the settings that we need? So these are the things that we need. And there's also requirements.txt file created. So everything that we need to replicate this model in a new environment is given to us. So which means we don't have to manually figure out as what is it that I have to take care if I'm moving this model to the another environment. It's given everything over here under the artifact. I just have to push this artifact to the new environment or integrate it with my current application that I've got and implement the CI/CD. So that's the best part about this MLflow library. I'll just come back to the home page. Over here, we can go ahead and add the various column. Like I can just select, see all the metrics and all the parameters. And if I run this again, let me do one thing. This time, I'm just not going to log the linear regression. Okay, I'm just going to keep only my this random forest model. Okay, I'll run this script again. Python main.py. So now this, okay, so I think we got an error that says, okay, so we are getting an error because it already exists. I'll just comment this for now so that this script can be run again. So normally we set a different value over there. So, okay, now it's done. It said created version 2 of the random forest model. I'll refresh the homepage of this MLflow. Okay, yeah. See, we have the other run that was created right here. This is a loud moose, and this was the one, and we have the random forest model. Now we can click on this chart view, and we can actually like view the various chart and see how exactly the model is performing, and we can configure the chart. Like for example, if I want to if I've experimented with various values of maximum depth, and if I want to observe how the R2 score was, I can go ahead and create a metric like this, like chart like this, and this will help me to understand how was the impact of a specific hyperparameter on the model performance. Okay, so overall, these experimenting tools, that is the MLFlow, it would help us in tracking the experiment in an efficient manner. And that would also help us in reproducing such experiment. And this is one of the common tool as a more of a data scientist and a machine learning engineers would use, so that we get to see the repeatable model performance in any environment. All right, guys. So this was about a quick learning on this ML flow. We'll talk more about on our weekend webinar. I hope you had fun learning in this video. So folks, if you want to join live from the next session, just check out the link that is provided in the description. Join our community, and I can't wait to help you in your MLOps and generative AI journey. Take care guys, and I'll see you next time.